So, for example, when we do have a tennis ball is thrown into a swimming pool from the top of a tall hotel, the height of the ball from the pool is modeled by that function in feet, where t is the time in seconds after the ball is thrown. We are asked how long will it take for the ball until it will be 144 feet above the pool. So we need to understand that d of t represents the height. It's the same thing as y. So our 144 is going to go in there. And when we put this in Wolfram and have it solve it for t, we are asking it to solve for the number of seconds that it will take for the ball to get to the pool. And let me fix this a bit. There we go. So you can see we do have a parabola here. And in most cases with problems in this section, we are going to have a solution that makes no sense. It's a mathematical solution, but it is not a solution that exists in the real world. We're going to ignore that solution. We are only going to pay attention to solutions that exist in the real world, because you are no longer living in math land, you are living in real world application land. So t equals negative 13 over 4. The only way that we are going to have negative time is if you were able to go back in time, and this is not Back to the Future. We have no DeLorean. So this answer is a throwaway answer because it does not exist. The answer that does exist is t equals 3. So I could put down t equals negative 13 over 4 and t equals 3. We are only going to pay attention to solutions in this course that exist in the real world. 3 is the only one that would exist, because if we went backwards 13 over 4 seconds, or about 3¼ seconds, the ball would not have been thrown yet, because it's before the ball was even thrown. So pay attention to your answer. And again, this course is all about making sense of what the number is that Wolfram spits out. So using that, as always, we put a sentence. It will take 3 seconds for the ball to be 144 feet above the pool. This must be an extremely tall building. There's part A. For part B, we are asked how long or when will the ball hit the pool. So we go back here. All we need to do is change our height to 0, because 0 is when it would basically be hitting the ground or the pool. Again, we get two solutions, one that is make-believe or doesn't exist in real life, and one that does. Let's go down here to see what we've got, and they both look extremely nasty. I don't expect you to give me either one of those solutions. I want the approximate forms. Again, a negative solution doesn't exist in real life in this case, because we are not traveling backwards in time. We are traveling only forwards in time. So that puts us at 4.2. I'll just stick with 4.2 seconds. So what we would do in that instance is we would use our formula. Put 0 in for the y value. And we end up with t equals, again, I'm only going to go to 4.2 and leave the rest of the decimals out. So the ball will hit the pool after 4.2 seconds. All right, with that, that's it for number 1. We'll be back for number 2 right now.